Hola, buenos días. Bueno, estamos contentos de recibir aquí de manera personal a Mehrdad Hejazi, de la Universidad de Isfahan. Es ingeniero civil, es una persona muy activa en el campo de la restauración de las estructuras históricas, también muy activa en el Comité Internacional de ISCARSAH del ICOMOS, que se ocupa de la restauración de estructuras históricas. Y estamos muy contentos de que esté aquí. Nos va a contar un poco la evolución entre BAM, la ciudad histórica de BAM, construida de tierra antes del terremoto, qué pasó después del terremoto y qué ha pasado después durante su reconstrucción. Os dejamos con él. Gracias.
Thank you very much for inviting me to make this presentation today. The presentation is about the BAM Citadel before and after the 2003 earthquake. The Citadel is one of the largest adobe in the world, and I'm going to explain what happened in 2003 and what was the action plan and the actions which were taken after the earthquake, and also I explained about a pilot project that were carried out. In 2003, there was a huge earthquake in BAM, which is in this part in southeast of the country. And it was quite a huge earthquake with a hypercenter of only 8 kilometers. And the vertical PGA was G, which is quite large, and horizontal PGA about 0.8 G. This is the situation in the main city with new buildings, and our focus is on the BAM Citadel. As you see, the Citadel used to be a small town with headquarters at the top, and people houses were around, and they used to live there until 100 years ago. But during the time of earthquake, it was empty. It was a touristic area. It's an aerial photo of the earthquake, and to the right you see the situation of the BAM in the bottom before and at the top after the earthquake. Around 80% of the buildings of the Citadel were somehow destroyed. This is before the earthquake. As you see, it was a touristic area, and every month thousands of tourists used to visit the Citadel. Some parts such as Meydan or Square or Jami Mosque you see here. Well, let's see what happened after the earthquake. You can see what was the extent of damage. More than 80% of the site were destroyed. This is the main entrance, and after that you couldn't find the entrance. Okay, let's go. If you have a look here, for example, some curved structures somehow had a good performance. It means that the other part might be collapsed, but these curved parts, such as arches and walls, they did not collapse, as you can see here. It means that when you use a specific type of shape of form for structural elements, somehow you can maintain its stability even during a severe earthquake. And here you see a pizza or rammed wall. As you know, a rammed wall is constructed in different layers. And between each layer, you have some sort of material such as adobe blocks or such as branches. As you can see here, most of the walls which were rammed, they did not collapse because of this type of construction. Even here, you can see that these buttresses, which were supposed to support the building, they were intact, and the building itself was collapsed. This means that during restoration, before the earthquake, some reconstruction works were not appropriate. Whether it was designed or not, I don't think so, and it means that some of restoration works were not good. But here in other side, you can see this wall has good performance. This is one of the towers which suffered a lot. Good. Let's compare the situation before and after. This is the main view or general view, the main gate, as you see, and this is from a different viewpoint of some of the towers, as you see here. Some of the towers were completely destroyed. As you compare the same places before and after. It is interesting that there was only one break building in the Citadel. It's a fire break building. It is the only element which was not suffered from the earthquake. But it doesn't mean that we should use break. No, we should use adobe, but I don't know by which reason they had used this break element here, and it was intact. Okay, this is a gate, as you can see, destroyed. The Caravanserai, most of that was destroyed. Even some wind towers worked there, which were destroyed. And here is tea house. It is in another part. It has a barrack, as you can see, destroyed, and it is the ramp to the barrack, and this is the governor house at the top of the hill, which was somehow destroyed. And also it had a watchtower, which its upper part was destroyed. If you look at the third sentence here, the Citadel was under restoration and reconstruction in some parts during 30 years before the earthquake. And after earthquake, we realized that inappropriate restoration methods were used in some parts. It means that if some parts were not restored, they would not got so much damage. If you have a look at the situation of the BAM Citadel just after the earthquake, and then 4 years later, no, it's the same year. Then 4 years later, you see some parts have been somehow restored. And you can see the percentage of damage in different parts of the citadel with different colors. It is interesting that the citadel was not inscribed in UNESCO World Heritage Sites. Why? I don't know why. But at the same time, it was an international commission to Iran to rescue the citadel. And they defined an action plan for 12 years. The first year, it was phase 1, the emergency measures. During next 2 years, it was phase 2, to do documentation, assessment, analysis, and planning. And then during next 10 years, in phase 3, it was long-term restoration and rehabilitation of BAM's cultural heritage, which was supposed to finish in 2015, which was about 10 years from now. The first year in phase 1, which was emergency measures, as you can see, the first part was to establish, I would say, to establish a cultural heritage camp in the BAM. The first year, which was the emergency measures, the most important thing was to establish a camp there and also do some on-site inspections, such as structural damages, geology, geotechnical conditions of the area, archaeology, and so on. In phase 1 was emergency measures, phase 2 documentation and assessment, as I explained before, and also phase 3 was a long-term restoration. The first actions which were took after the earthquake, they just established a camp for the researchers and also for the guests who came there. One of the main problems was removing the debris. If you have a look here, you can see the debris all around the citadel had a height of at least 2 meters. Millions of tons of debris should be removed, and it was itself a plan and a project. And as you can see here, it is the debris removal paths. The thing was, some of the debris could be used. Most of them could not be used. Therefore, they had to separate them and decide what to do. And in order to remove them, it was a quite big work, which took, I think, more than 2 years to remove all of them. Some safety measures were taken in order to make sure there is no collapse for the people who are working there. And also, one of the first steps was establishment of an Adobe laboratory, as you can see here, in order to test the existing materials, and also they had to find a quarry for suitable soil in order to make new adobe. And for this they had to go and visit many quarries, make some tests, and then they were able to find the best quarry for the soil in order to reproduce some materials. Some activities were conducted for geological studies to find out suitable soil, structural studies, GIS plan, restoration plan for different parts, landscape pathology, and so on. Here you can see well, at that time, actually the buffer zone was not fixed. It was a good situation that they started to define the buffer zone and the main zone. Also, they did laser scanning. At that time, laser scanning was a new method. And it had two parts. First was doing the laser scanning and then to process. And we did it, and it was quite a big job that they did, as you can see here. And also the pathology was done. It was interesting that when some of the walls were destroyed, when I say wall, it means that the height is more than 20 meters and the thickness is sometimes more than 10 meters. And each wall was made of 2, 3, or 4 layers. Some of the walls, when they were destroyed, some archaeological items were appeared. And therefore archaeologists were so happy to find something, but it was a disaster for the restorers because they could not start their restoration work until the work of archaeologists were finished. It was important to send the message all around the world in order to ask the experts to come and help Iranian experts. And there was international workshop the next day, the next year, and UNESCO experts came there. And in 2004, the Citadel was inscribed in UNESCO World Heritage Site in danger, which was good. We could get funding from international committees, and also international experts were able to come to Iran and do their job. As I explained, because there was a disaster, most of the restorations performed during the last 30 years were all destroyed. It meant that there was a problem there, and we had to, or we wanted to, increase the ability of Iranian restorers to enhance their methods. For this reason, 5 projects were selected and given to 5 different countries. 1 to Germany, 1 to Italy, 1 to Japan, 1 to France, and the second one again to Germany. And at the same time, 2 projects were given to Iranian experts. And each group selected 1 project, and they carried out their own approach. Therefore, now we have German, French, Italian, Japanese, and Iranian approaches there. Buildings are restored. The reason is to see what would happen in next earthquake. If we have another earthquake in 30 years ago or 50 years ago, I don't know, that would be a good comparison. At the same time, when 5 groups from 5 different countries were working together, somehow they could get connected and get familiar with each other. We established Adobe laboratory. As you can see here, some natural fibers was going to be used for restoration. Also, this is the type of adobe which were constructed. As you can see here, you see some cracks. There was a big problem that when we wanted to use traditional methods, traditional masons, they could do it. But when we gave the adobe to universities to make adobe, this is the product, as you can see. It took a few months for universities to be able to produce adobe without cracks, and also somehow to improve the strength and so on. I'm not going to detail. Grouting and injection was one important thing, because some cracks could be injected, and one of the groups suggested adding cement, which was not accepted by the steering committee, and we used natural materials for grouting and injection, which was done with a group from Tehran, and they were able to do the grouting, and also they did some tests in order to make sure it is compatible with the adobe. This is the one of German projects. We called it Sistanis House, one of the most important houses there. Professor Jäger, you see here from Dresden, TU Dresden, he came there with his group, and they used German techniques. As you can see, they used some elements in order to with tensile strength, and also they confined the walls, for example, from two sides, and also they connected the walls towards the ground in order to prevent uplift during the earthquake. Because in BAM, one problem was the vertical GPA was 1G. It means that the buildings had an uplift force which was equal to G. It means that they were weightless somehow. And at the same time, there was a horizontal force which destroyed everything. The German method was somehow to keep or to attach the building to the ground. Project number 4 was given to Italians. This is Professor Croci. At the same time, he was the president of ISCARSAH, and they took the tower number 1. It was the main tower in the Citadel, and it was somehow completely destroyed. And it was a big job they started, and you see, this is the method they used. They used geogrids, because they told they had used the same method in previous locations with success, and therefore there was no problem. They did it. As you can see here, this is what they are doing for tower number 1. Tower number 32, this tower was given to my university. It was not just the tower, but also the wall, the other side was completely destroyed, but the tower was somehow intact. I would say it had only a few cracks, this part and this part. But when we did some research, as you can see here, we dug inside, we realized that the tower was made of 3 layers. And the main core, the main layer was in a good condition, but the other layers were somehow cracked. And there, somehow we decided to use nailing for that. But before that, we did some material testing. We got its strength. We did some structural analysis after we knew which layers it had. We used the same earthquake with also the earthquake of Iranian earthquake standard, and we did a calibration to get the same damage in our model. And after we got the same damage in our model, we were able to introduce some sort of nailing, and which you can see here. Even here we had a wall which was destroyed, and we decided, and we had some photos from previous years, and we realized that in even previous years this building, this wall was destroyed somehow in this part, and we decided to make a junction here. We somehow in reconstruction we did not connect the two parts of the wall together. The other problem was these parts at the top of the wall, as you can see here. Most of them were destroyed, and we used or added some elements inside to prevent. The other one project was also given to German. The same to not to professor, but to one of his colleagues who is Iranian, and he used natural fibers to see whether it works or not, and he did it. We don't know it works or not. Maybe in next few years we see it. The other was given to another Iranian group, which was using geogrid mesh, and some of the walls were strengthened with this method, as you can see. The other was given to a Japanese colleague, Mie University, and it was a small adobe house, and we used the wooden vertical and horizontal elements in order to strengthen the building and also to reconstruct the walls as it was before the earthquake, and also some other projects for using natural fibers and so on were used, as you can see here. Well, also there we established a laboratory on free environment, and different groups could do some tests, some structural engineers, some architects, and so on. But let's see what is the current condition. We never used cement to stabilize the adobe. We never used compaction, because there was a national steering committee. They decided what to do. Yeah, if we compact adobe, the strength would increase much. But they said, okay, as you can see here, we have an intangible heritage there. An intangible heritage is the workers who are working there, who's been there for many centuries, and they are using the same. As you can see, this is the method. Still, they produce adobe. Okay. This is the main gate. At the moment, if you go, you can see it. The main gate was a project done one of the groups. It was an Iranian group. Here, from inside, this is the situation, and here. At the upper part, the upper part is restored, and the bottom part is not restored. Because if we wanted to restore everything, in other way, if we wanted to reconstruct everything, we don't do that in Iran. If such a citadel is completely destroyed, we usually reconstruct the main landmarks. And usually we don't reconstruct the other parts in order to show something has been there, and in future, if there are some techniques, some enough money, and some experts, they can do it. Even here, it is the part in the left-hand part. As you can see, it seems that it is damaged, but it is not damaged. It is after restoration. It is not plastered on purpose to show the people who come here, look, sometime there was an earthquake here, and this is the situation of earthquake. The other side to the left, it is reconstructed or it is restored. The situation under the plaster is like this. But why we use plaster? Because there is rain, there is snow there. In order to protect the main structure, we use the plaster. But this is the sign of what happened at that time. And here it is the situation at the same time, at the current time. If you have a look here, I will go there later on. If you have a look here, still there are some elements here. There are some supporting elements. At the moment, they decided to leave it here until this part is completed. Even some parts here are still under restoration and maintenance. And if you have a look at behind of this part, it is like this. These buttresses are new buttresses. Before earthquake, there was no buttresses, but because this part wholly was destroyed, they decided to strengthen this, and the strengthening is in a traditional method, as you can see. Even me or those who have reconstructed know these are new, not. And even here, if you have a look from here again, the upper part is the part which is not restored. It is just protected with some layers. But this part here is reconstructed. Therefore, in Persian restoration, what we do is we put some signs of damage, as it was as a history of the building. Now, if you have a look from outside, this is the situation of the citadel. There is no water there. They are making clay by water, but there was a photographer at that time and took this picture. Usually, you don't see such. And if you go there during the night, it's like this. It means now Citadel is alive. And people go there, and it is not only a tangible heritage, but it is also an intangible heritage. Those people who live in BAM for their ceremonies, it could be a marriage or it could be a death, they go there. And it means that BIM Citadel is somehow a part of the communities in BAM. The earthquake in BAM was a great experience. 5 countries contributed. All their matters are documented. And Iranian also got many information from foreigners and so on. And we hope that this international or UNESCO site could be beneficial to all humanity. Therefore, to conclude, it was an opportunity to test different restoration methods and also to keep traditional methods for future generations. I thank you very much for your attention, and if there is a question, I'm ready to answer. Thank you very much.
You have a question? I have a question too.
Thanks. First of all, congratulations for this presentation. It's very interesting to see before and after the intervention, after the earthquake. I wanted to ask you, how was the intangible heritage managed in the traditional construction techniques used in Citadel? Was there any involvement with collaboration with local organizations or any link with because I understand that these methods of constructions, they're still alive, or how was the involucration with the people with this building and the new intervention? Thanks.
Okay, thank you. If I got correctly your question, first, this citadel was a part of life of people in BAM. Sometimes you have some historical buildings, which is a touristic. You sell a ticket, people go there and come out. But this is not like that. And people, even they did these ceremonies there. Therefore, when it was destroyed, it was a big disaster for the community, for the people. The methods that was used for reconstruction of landmarks were well documented. Yearly workshops were there. This is what we're seeing at the moment. Looking at it's just after the earthquake, but after that, every year there was such a workshop there, and different people, different experts presented what they had done. Everything was documented, and at the same time there was some pathways inside the citadel that let people come in. It was open to public to see what is going on there, because the people were very important. Even sometimes they ask people, look, we are doing this. We are going to start with this part, and then we will do that part later on, for example, and that's it. And because people got involved, they encouraged everything, and I think at the moment, first we have a good documentation of the citadel with different people. Still, we have a connection with them, and now people know that it was important for them for the, I would say, the authorities. It was important to them. The other thing that I forgot to say was during the earthquake, about 40,000 of people were died. 40,000 of people died inside the city of Bam. And most of the buildings which were destroyed were newly built building. You know, concrete and steel buildings. And also, many adobe buildings were also collapsed. But it was very important for people that even in adobe buildings, we can live without any scaring from the earthquake. And therefore, I think this somehow, by this earthquake, people somehow got more involved to the citadel and its activities. I don't know whether I could answer your question or not. Okay, thank you.
I have some short questions.
Yeah.
You said that the adobe was not compacted, but when you are making adobe, traditionally you throw literally the earth into the mold, like giving a little compaction. You mean that it was not compressed by a machine or something like that? Is that right?
Yes. It was not compressed by machine, but by hand they do it.
Okay.
Yeah.
Yes.
Thank you for correcting me.
Yeah. Second, no, it's not, just to know. Second, the renderings we are looking at are earth-based, are earth and straw, are some lime, or which these renderings are what?
Only earth.
Only earth.
Yes, if you have a look here, to the left here, it is earth. Then sometimes they add some mud, straw, if it is necessary, less than 1%, something like that. And then they add water, but more than 70% of the soil is clay.
And it doesn't crack.
No, it is clay, which is it is very I would say, it is clay.
Uh-huh.
And there is no lime added at all.
Okay.
Yes, if we add lime, it would increase the strength. But the thing is, because this has been used for more than 2,000 years ago, this method, they didn't accept the steering committee to use machine compacting for adobe and adding additional additives.
And the mortar is earth. Only.
Earth.
Clay.
Clay.
So,
yeah.
which is the maintenance of the rendering? How?
Maude straw.
Yes, but how many years you have to remake the rendering? Is there any maintenance, traditional system or period or?
It depends. It has a periodical, I would say, it's a periodical surveillance. We just go there and we see, oh, well, if it is needed to repair, we repair it. If you have a look here, it is on the facade. Usually facades every 5 years.
Okay.
But when it is on the roof, sometimes it could be 2 or 3 years every year.
Because the roof are compacted earth.
Yes.
How many centimeters?
It is 2 layers. One layer which is compacted is around 5 centimeters, and there's a protective layer which has maude straw also. It is maude straw. It has a straw. It is about maximum 2 centimeters.
Okay, so it's only like 7 centimeters.
Yeah, maximum, even sometimes less.
Like and the slope, more or less? Is
Yeah. They make a slope for that. It means that, like here, if you have a look at this one, it has a slope. On the roofs also they have a slope of 1%, something like that.
Only that?
Yeah. Okay. And you see gutters there. If you have a look there, on the top you have gutters. And they have gutters, and it conveys to the gutters,
Okay. And last question, you saw a vault with a rope on it, a reinforcement with rope.
Yes. This one.
Yes. So what are they doing on top of it? They are rendering, or they're putting another Adobe?
Yes. They would put compacted earth on it.
Yes.
Because even it could be some 10 centimeters, something like that.
Okay.
Because they want to somehow to connect the different parts below and above the fiber together.
Okay. Is it nailed on it?
It is nailed.
Okay.
Yeah, somehow. Yeah, somehow it is connected there.
And it is on tension?
Yes, it is.
On tension.
Yeah. It is post tension somehow.
Okay, that's very interesting.
Yeah. Even you can see here. And then when it is compact earth is there, then again they put a smaller compact and mud straw on top.
Okay, and which type of string is this? Is natural string like?
Yeah. It is just palm. Yeah.
Palm. Okay.
Yeah. Because the economy of there is palm tree. I would say date.
Okay.
I would say that there is a canal system underground, and the canal system was fortunately not destroyed. Because if the water system was destroyed, the economy of the people would be destroyed, and they had to leave the city. And yes, because as you can see here, these ropes are made of palm trees.
Okay. Very interesting. Thank you very much.
Thank you very much. Thanks for your question.